Hello anatomy students and greetings from home quarantine. This video is going to be on the tissue identification review, I should say, in preparation for your tissue picture quiz coming up in the next few days. So this is just me walking through all of the different tissues and the pictures that you will see, or at least the pictures I will choose from to make your video/picture quiz. All right, and it's just me walking through some of the distinguishing characteristics in a video for you to use to study. All right, so let's go ahead. It's kind of long, so buckle up and get ready. Well, let's go ahead and get started. All right, guys, this is going to be for video review. Let's go through the tissues right out of the PowerPoint from the publisher. That is strictly all of the illustrations in their PowerPoint. So let's just go through and examine the characteristics of these different tissues. So let's go ahead and start the slideshow. All right, let's review real quick. Remember the rules that are followed. Simple is one cell. One cell is pseudostratified. They look like more than one, but they're really one layer. And multiple layers are stratified. The cell shapes are squamous is flat. If they are the same width as they are tall, they are said to be cuboidal. And then if they are much taller than they are wide, they are said to be columnar. Okay, so let's take a look. We are dealing, because this area is connective tissue, we are only talking about these cells right here. All right, so flat cells, and because they're flat and it's one layer, they would be simple squamous. And this is the artistic version. So we see one layer, flat cells. So this would be simple squamous. Okay, next we move on to the blood capillaries inside the kidney, the tubules inside the kidney. And we're looking at this spot right here, but we're going to zoom in, and we're going from here because this is connective tissue, not epithelial tissue. And the question is epithelium. And that's how I'll word it. What kind of epithelial tissue is this? We're going from here to here. So this is a single layer of cube-shaped cells. So that is simple columnar. And then here is the artistic version. One layer. They are about the same width as they are tall. So that is simple cuboidal epithelial tissue. Now we move on to the area inside the small intestines. Okay. Again, we are identifying this area as connective tissue. So that means we are only going from here up to here. And that means we have one layer. You can see the nuclei are all nice and lined up for us. So this is one layer. And obviously these cells are much taller than they are wide. So this would be simple columnar. And they actually point out that it's non-ciliated, meaning it has no cilia. So here is that same picture we saw a little while ago. This is a single layer, one layer of cells, and they are, again, much taller than they are wide. So this is simple columnar, and it contains microvilli, not cilia. Okay, here we have, again, connective tissue. So we're not looking at this epithelial. All right. And we see from here, they actually bracket it for us from here to here. This would be inside the fallopian tube. And this contains cilia, but this is definitely just one layer. It's not very confusing to see. The nuclei are all pretty well lined up. So this would be ciliated simple columnar epithelial tissue. And here is the artistic version. So we see the cilia on top. Hopefully we can tell the difference between cilia and microvilli. Again, we see the goblet cell producing mucus. The nuclei are in a pretty good line. So this is definitely telling us we're clearly just one layer of very tall cells. So this would be ciliated simple columnar. Now we move on to the trachea. We again see cilia, but as we look, these cells are kind of funky shaped, and the nuclei are not in a single row for us. They're kind of in two rows. And since we're talking about the trachea, this is a classic spot for pseudostratified. And because it contains cilia, we would say that it is pseudostratified ciliated columnar epithelium, my favorite epithelial tissue to say, just because it flows right off the tongue. Pseudostratified ciliated columnar epithelium. You know you want to try it. And then here's the artistic version. Again, we see the cilia, we see the goblet cells. Some of the cells appear to not touch the bottom and the top or basement and apical surfaces, but they do. It's just they have a weird shape. So this, again, would be pseudostratified ciliated columnar epithelium. All right, moving on, we see this is one of the differences between stratified squamous of your skin and other areas of the body. This is non-keratinized, meaning it doesn't contain keratin. Keratin is the waterproofing agent of your skin and is ultimately what causes the outer layer of your skin cells to die. They get packed full of keratin, and they lose all their organelles, and they become dead cells. Same thing with your hair and your fingernails. Those are keratinized cells. These are stacked in obviously multiple rows. They are flat. So this would be non-keratinized stratified squamous epithelial tissue. And here is the artistic version. Remember, in naming, so down here they have a cuboidal appearance. But remember, when we're naming epithelial tissue, we always go with the shape of the cells that are on the apical surface, which are flat. So we see multiple layers and we see flat cells on top. So this would be stratified, non-keratinized stratified squamous. And we go to the skin where the cells are dead. This is the same, but different because they contain keratin. So this would be considered keratinized stratified squamous. And we'll move on to the esophagus. So now we're going to come into this area right here. So this is connective tissue. We're talking about from here to here. We zoom in from here to here. We see two nuclei, which tells us this is going to be two layers of cuboidal shaped cells, because here's a nucleus there, here's a nucleus there. So this is going to be stratified cuboidal. It's only two layers, but remember, as long as it's more than one, it's considered stratified. And here's the artistic version. So 1 and 2, because remember, to be simple, the cells that touch the bottom have to also be exposed to the apical surface. And clearly this cell is not. I don't know why it keeps giving me that extra line there, but this cell is not exposed to the apical surface. So this is stratified cuboidal. All right, here's one of the rare instances we find stratified columnar. So here's a row of nuclei. Here's a very distinct row of nuclei. And if you look faintly, you can see the plasma membrane here. So this is two layers of very tall cells. So this would be stratified columnar. And here's the artistic version. Down here, they're kind of funky shaped. They're not as tall as the ones out here. But remember, the rule is which ones do we have out here? And that would be the stratified columnar. So those are columnar shaped that are exposed to the apical surface. So that's the name we give them, columnar. And more than one layer, so it's stratified columnar. Then we come to the leftover epithelial tissue, the kind that's very unique. and that is what we see in areas of great stretch. So we go to the urinary bladder. Here's your dead giveaway that we're talking about transitional epithelial tissue. So here, this bladder is not stretched, so they have a cuboidal shape, and we see multiple layers, and they're all kind of just piled up, not in a very good order. Then we recognize that as transitional epithelial tissue. The dead giveaway is, hey, we're talking about what's in the bladder. And we know the bladder, the urinary bladder, goes through great stretch. So it's going to contain transitional epithelial tissue. And here's the artistic version. So this, because these cells are not flattened, this would be a bladder that's not stretched out. Now we see a bladder that is stretched out. So here, imagine that this area is full of urine, and we see this cell is flattened out because this tissue is being stretched. So it's still transitional, but it has a different appearance due to the amount of distension that the bladder is experiencing. Now we'll move on to the gland. We find glandular tissue. We're talking about this row right here. That would be simple cuboidal inside the gland of the thyroid gland. And then here we see it again. Simple, if I ask what is the epithelial tissue, that would be simple cuboidal. And we move on to the sweat gland. So we're talking about the tissue that's in here. And we see one row of nuclei here, but this is kind of jumbled up, and it kind of looks as though there's multiple. So the real picture of this one is tricky, but in reality, there is multiple layers. So we're going to go with this being stratified cuboidal. And I will ask again, identify. I will actually have in the question, I will have the word epithelial tissue. So if you see epithelial tissue, then you know we're looking for, stratified squamous, simple columnar, something along those lines. If I want connective tissue, I'll ask, what kind of connective tissue is this? So as not to make things confusing for you. More confusing than they already are. All right, so here's that general overview of connective tissue. This is really no particular kind. It just is a generalized view because it has everything. So it contains the fibroblast, which is the cell making all the fibers. You have white blood cells. You have the macrophage. You have collagen fibers, elastic fibers, the ground substance. Remember, that's the stuff that is the extracellular matrix. So that is, remember my analogy from the other day, that would be the peanut butter in the crunchy peanut butter analogy. We also see the reticular fibers. This is the type of connective. This is a connective tissue that has it all. So it's just a general, it's no particular kind. This is a particular kind of connective tissue. So remember, we have loose, we have dense, we have cartilage. Those are your three big types of connective tissue. So these first few are going to be different kinds of loose connective tissue. And the first kind is areolar. Its characteristic that makes it stand out to me is how loose everything seems to be packed. There's a lot of space in between all of these fibers. The cells are spread out, right? And you have all of this that just seems to be nothingness in the extracellular. Things are not densely packed. There seems to be a lot of open space. And that's the dead giveaway that we're looking at areolar connective tissue. And here's the artistic version. As you can see, there just seems to be a lot of space in between the fibers. And that would tell us that we're dealing with areolar connective tissue. Then we move to fat. Technically, it is adipose tissue, and it stores fat. So the name of the tissue isn't fat. This is the tissue that stores the substance of fat. So this cell is one cell in the type of loose connective tissue that is known as adipose connective tissue. And now here's the artistic version. So this cell would be full of fat, and this tissue that stores the fat is adipose tissue. And then we go to the other kind of loose connective tissue, and that is reticular. You can see it is more densely packed than the areolar, but there are still some open spaces, but it just looks tougher and thicker. And it has a lot of reticular fibers, and that is how it got its name, the loose reticular connective tissue. And here is the artistic version. So again, open spaces, but the fibers are thicker. The cells are a little more densely packed, not as sparsely populated as they are in areolar, and that's what helps it stand out from the areolar connective tissue. Next, we move to dense connective tissue. This is a tendon. So we see the fibers all running in the same direction. They look nice and organized and all running in the same direction, very parallel, neatly stacked. So this is what tells us that we're dealing with dense, regular connective tissue. And here's the artistic version. Again, all of the fibers, although they're a little wavy, but they are wavy in the same direction. So dense, regular. This is dense, irregular. And if you look closely, you can see some of these fibers are running this way. This fiber is probably running diagonally, kind of going towards us from left to right. These fibers are probably running straight at us. So they're all going in different directions. And this would be dense, irregular, because the fibers are running in multiple different directions, and they seem to be very irregular in their arrangement and random. So we see it again here. These are running towards us. These are running from right to left, and you can just tell that they are very haphazardly organized, and that tells us irregular, dense, irregular. Here we have the dense elastic connective tissue, and we can see these elastic fibers are all piled up. So imagine if you took rubber bands and laid them, stacked them nice and neatly together. It's kind of what they would look like. Very dark, clearly a dense kind of connective tissue, because there does not seem to be a lot of empty open space in between. So this would be dense elastic. Then here is the artistic version. You can see those elastic fibers all nice and kind of lying in order and running in the same direction. Next, we move to cartilage. This is the type of cartilage called hyaline cartilage. One of my favorite, because to me, it looks like it contains Google eyes. For some reason, a lot of times the cells are right next to each other. You see two of them together. And usually the way they pair off, they kind of remind me of googly eyes. So every time I see this kind of cartilage, I know it is hyaline cartilage. And here is the artistic version. And I'm sorry, but if that doesn't look like a pair of googly eyes, then I can't work with you. You just don't have a good sense of vision there to be able to tell me that those are googly eyes. I don't care what anybody says. Next, we move on to fibrocartilage. It gets its name because it contains a lot of collagen fibers, and it is very tough and fibrous kind of cartilage. It doesn't look as thick as the hyaline with the extracellular matrix, but it is very tough and doesn't look as smooth to me. If you go back and look at hyaline, that cartilage seems very smooth. This cartilage doesn't seem very smooth to me, and that would make it a tougher, a rougher looking cartilage, and that's our big giveaway that it is fibrocartilage. And here is the artistic version. So we can see these fibers, these densely packed collagen fibers running through the extracellular matrix. And the last kind of cartilage is elastic cartilage, not to be confused with dense elastic tissue. This is elastic cartilage, and we see this in areas of great flexibility and stretch. So your ear, the pinna or auricle of your ear is very flexible. You can bend it and fold it and pry it and do all kinds of different things with it. Very flexible, and that is the elastic cartilage. And we can see everything's very all the same colors. You can see the fibers are kind of a web of a network, and that's what gives it its flexibility. And here's the artistic version, all the cells and the elastic fibers, all giving it its very flexible nature. And then we move to bone. Bone is a type of connective tissue that stands all by itself. It's very dry compared to the others. It is a hard kind of connective tissue, and it has it has what we call the concentric ring arrangement. So this is one of those ring systems, and it kind of resembles tree rings. So here is the middle, the central or Haversian canal, and you can see these bone cells, these osteocytes here, spread out in the ground substance or extracellular matrix, and it kind of gives the appearance of tree rings. So this is one of those canal systems. And if you look at the larger picture, the less magnified picture, you can see here's a system here, here's one here, here's one here. You've got another one there. So they're all packed in together, making the tissue, the connective tissue, known as bone. And here is a very magnified version of just one of the bone cells. So if we go back and look, we're talking about just this spot right here. This next picture, that's that whole thing. So we've just zoomed in on that chamber where a bone cell or an osteocyte is housed. So this would be a very magnified picture of bone tissue. And then the remaining connective tissue is blood, although it's kind of weird. Blood doesn't really connect anything, but it is considered a connective tissue. And this one has all three of the main components of blood. So the fluid of blood is the plasma. So that's where all of the fluid is going to be in between all of these cells. And it would be considered your extracellular matrix. This is a white blood cell. That's this guy right here. All of these that kind of look like little cough drops with their depression in the middle are red blood cells. And these little guys right here and right here, and they magnified one right there, those are platelets. That's what enables our blood to clot. So this looks like a whole bunch of cough drops lying on the table. This is blood. And here the difference. We have the red blood cells. Like I said, they kind of resemble a lozenge, a cough drop. You have different kinds of white blood cells. We'll get into that when we get into the cardiovascular system. And then the little blood clotting agents, the platelets. And now we're going to move on to the different kinds of muscle tissue. So these fibers, this is one muscle fiber or muscle cell. This is one muscle fiber or muscle cell. We can see it is clearly banded or has those striations, and we see 1, 2, 3, 4, 5, 6, or 7 nuclei embedded within these cells. So this is going to be a clear representation of skeletal muscle fiber. This is also striated, but it has more branching. See, there's a branch here, there's a branch there, and embedded within them are these dark lines that run the same direction of the striations. So this muscle tissue is striated. It only has one nucleus per cell, but it contains the dead giveaway are these dark bands right here. And those dark bands are called intercalated discs, and they are the clear characteristic that separates this kind of striated muscle from skeletal muscle, and this is cardiac muscle tissue. Next is smooth muscle, and you can see there's no striations, only one nucleus. It just looks smoother than the striated muscle. That striated muscle kind of gives it, the striations kind of give it a washboard appearance, but here they are not in that appearance, and their name actually describes their appearance, and they are smooth muscle tissue. So again, if you see this picture, I won't just ask what kind of tissue, I will actually ask what kind of muscle tissue are we looking at. Wow, I don't know why it keeps giving me those lines to shoot out there. So I will help you narrow it down when asking you to ID it. And then we move to the last kind of tissue, that is just nervous tissue. So here again is the artistic version of the cell with the dendrites. Those are the receivers, and then they send the signal down the line, and that's the axon. Here is an actual nervous tissue cell taken from the body. So here's the cell body. These are the dendrites, and the big one that runs down here is the axon. And remember, these cells are a one-way street. The signal only goes this way. It does not go this way, only in one direction, and that is toward the axon. All right, that's going to be our last one in our tissue identification video. So use this to help you study for your tissue identification picture test coming up. All right, that's it. Hopefully you're still with me. Don't forget, your picture quiz is coming up, and all of the pictures I use will come from this PowerPoint that's on this video. So this would be a good video to study. And like a true good YouTuber, don't forget to click like and subscribe. Thanks for watching. We'll talk to you later.